All right, welcome everybody. Thank you so much for joining today for Glazing for Schools. This is presented by the team at Guardian Glass. We've got Kreg here, he's going to be giving the presentation, and we've also got Tuan and Wendy here to answer any questions. So I just want to encourage folks to please submit questions to the Q&A throughout today's event. That'll give us a record so that we can talk through some of them at the end of the webinar, and we also will have a record of any questions that we don't get to so that you can be followed up with after today's event, just in case we don't get to yours. I'm going to pass it over to my colleague, Helen. Helen is Acelab's Director of Architect Experience. Acelab is helping out with hosting today's event, and Helen's going to give a quick little intro about Acelab, show you guys how to get in touch with the team at Guardian Glass on Acelab directly if you have some questions after today's event, and then we'll go ahead and get started with today's CEU course. Kreg, would you mind stopping your screen share for a moment just to give Helen control for a second, and then we'll jump back into your slides?
Yep, there you go.
Yeah.
Thank y'all so much. Yes, as Bo mentioned, I am the Director of Architect Experience here. My job's making sure y'all as architects have a good time, find what you need on the platform. I myself used to practice. It's really funny, actually, Kreg, I just saw on that slide, I used to know that photographer. We used to work together before
Oh, nice.
went out. So small world is always in architecture. One other thing for y'all to note who are attending today is that my colleague Evelyn and myself will be following up with you if you're interested. So you'll most likely see a conversation created within your Acelab platform there with some follow-up stuff from us. So keep a lookout for that. You'll get an email notification when that's happened as well. Quickly, I'll go as quickly as I can, but Acelab's a great spot to get in touch with folks like these people at Guardian. It's a great place to do some searches as well. So I'm going to do a quick little search here on glazing, which is relevant to these friends here. Just kind of walk y'all through what this looks like. This will be different across each of these product categories, the questions that we have, but I'm going to go for bird-friendly glass here. Here I'd select the project I'm working on. You can organize and collaborate on a per project basis in Acelab. This is an important step that I'm encouraging folks to explore. We have 7 search results. That's a pretty, tenable amount that we could work through. But sometimes if you have a ton of things or you're looking for something very specific, feel free to live chat us or hit this button here. What that does is it comes into our team with these wonderful, experienced folks, and we work through your question and come up with some recommendations for you. So for example, here's one. We were looking at vapor barriers for hot and humid climate. This architect didn't have a lot of experience in that area. They messaged us. We were able to put together this kind of comparison for them. Here's the products. Here's some different information. Here's all the performance data. So this is an option for y'all. This is also free. Please use it. We want to help you find what you need for your projects, just like these folks at Guardian. I'm going to skip and show results. Turn this on manufacturer view, and now you can see all the different options across the different folks that meet that criteria, including these wonderful people at Guardian. So here I can save this, create a short list, and I can also connect directly here with Kreg, which again will cause a conversation here. So, hey Kreg, I'm looking at this. What's the pricing and lead time? That kind of thing can all be handled within Acelab. Also, if you know that you want to use, say, Guardian, you can just type in their name up here. Make sure, oops, we've got a little block there. Make sure you select brands, and then you can go to their page and you'll be able to see all of the products that they have across the different categories, and then you can also connect with them here. So lots of ways to get in touch, and we're just here to help. So let us know how we can. I'll pass it back. Thank y'all.
There we go. Thank you, Helen, so much for that. I'm going to launch a quick poll. So if you're interested in meeting with Helen to explore more of Acelab or get some help with following up with the team at Guardian Glass after today's event, feel free to say yes to this poll. And we'll reach out to you and set up a quick 15-minute session. One last housekeeping item from me. We did ask for AIA numbers upon registration. I'll also send over a form in the chat momentarily, just in case you are worried that you didn't submit your number there. You can submit it to us that way. All right, without further ado, Kreg, thank you so much for joining today and giving today's presentation. Feel free to get started whenever you're ready.
Perfect, I appreciate it. Okay, so I'm sharing my screen here. So everybody see my screen without the notes in there? So looks good. Okay, perfect. I appreciate everything. Bo and the team at Acelab letting us come in here today. So just want to first introduce myself. My name is Kreg Hatfield. I'm the Regional Architectural Manager for our architectural team on the Western US. Also on this call is Tuan Tran. He is my counterpart on the Eastern US markets. So again, our teams combined work with most of the major architects in most of the major cities here as well. And then we also have Wendy Walker. She's part of our inside sales team. Again, that a lot of times if you guys put in a lead with Acelab, it will go directly to Wendy, and then she's going to help us facilitate through those and get those questions back answered to you. I did like that Helen kind of brought up bird-friendly glass as well. So we do have this AIA presentation on glass for schools or glazing for schools, but we also have several other CEU presentations if you ever want something in person. I believe we're getting ready to do the bird-friendly one the next time that Guardian presents on Acelab. So but bird-friendly glass is another option we do have as well. So so as we're kind of rolling through this, we are be talking about glass and glazing for schools and those different applications inside there. But the first thing, just want to, it is an AIA accredited presentation with one lead credit. And then some of our learning objectives today, when you're looking at schools and designing schools with glass, you really got to look at a lot of unique and different designs than you would for a mixed use development or other applications in there, and just understanding, what those attributes are and how they can add value, the cost implications of some of those, how we can help save you money inside of there, understanding what low E coating might work best for the school, or even the substrate of glass, or what we're talking about that, the actual glass itself, and then what type of fabrication systems and glass types might be in there. But so when you're designing for schools, I think it's really important to understand what's the objectives of the system, because schools can serve in multiple functions throughout that. It's going to spark learning. Some might be in athletic or even a physical development, a gym, those applications. Now that we're looking at some other options as well, with all the different elements that's going on with safety for the schools, child welfare, and how can it promote health and participation inside that school to be more active, bringing that active environment from looking outside in. So the more, there's a lot of studies out there that show that the more light allowed into the building for a school, the higher the test scores, the more development that's going to happen inside those schools, and it's going to spark a lot more learning. But then when you start to design schools, what are we looking for? Is there going to be glare that's going to come into those school buildings as well? And how do we kind of boost the mood and not make it look like a prison? I always remember my high school as a kid, and from the outside in looking at it now, it looked like kind of like a prison almost, where there was really small windows. There just wasn't a lot of light that came into the building. So how do we promote a healthy and well-being building for those students, but also give them some safety and comfort inside there as well? Also with meeting the budget constraint that the school system might have as well. And then really, what's the opportunities? Again, budget constraints, competitive bidding process. Again, we understand with competitive bidding that it does have to come down to, 3 different manufacturers, but how do we get all 3 manufacturers to be really aligned on what we're looking at? And then what type of value of the glass for the school? What are we really trying to design? What are we trying to understand with the system? And how do we bring the most value for that school, but also meeting the constraints in the design budget that the client has as well? So vestibules, glass is very versatile when you look at it. You can do it outside, inside. You can do vestibules for the inside application, handrails, guardrails, classroom doors, walls, a lot of things like that. But then on the outside, you've got all of your fenestration on there. You've got your atriums, entry doors, canopies. There's a lot of different options that we're seeing inside the school system that you can really use glass for and really be a part of bringing that light and bringing that development from outside in. And then what type of glass do we need to select to boost productivity, well-being, save some energy as well inside the system? And I think those are all 3 things that kind of go hand in hand, is how do we boost productivity, make it well-being, but also saving the client money long-term down the road. By having a lower solar heat gain, still allowing a lot of light in there, you can save money, but boosting that productivity long-term for those students is really, really important when you're looking at that. So what are we selecting it for? What type of environment, as far as the climate conditions for outside in? Is it, does a lot of the light going to face from the west side of the building to the east, or is it more north and south, or you're going to have a lot of light coming in there? Because all these can be designed in different applications to allow that. So those are things that we need to look at as well inside the system, as far as what happens and what you have running up against. Okay. And then we need to look at the impact as well. Unfortunately, with what's going on in society right now, we do need to look at how that impact for safety can be in that building. But we can also look at safety in other ways. I mean, what type of glass do we need to put inside of a gymnasium, or if it's a swimming pool application, what type of glass is going to be the most important for those safety aspects to keep the students safe, but also keep the building functioning and not replacing lights right and left because, you know, a soccer ball gets kicked into the glass and breaks it. So we need to look at a lot of different impacts, and not just safety for the students, but safety is the overall constraint on them. Next, we need to understand what's the aesthetic goal of the client. Do they have any certain colors they were trying to go after, or any certain amount of look that the building needs to have? Does it need to be something like this where you can see in there some inner layers that makes the glass change a little bit of color? Do they want some spandrel to be included in the glazing to make it stand out, or just really blend in? So we need to also look at not just the safety of the building, but what's the aesthetic goals of the building as well when we're selecting the glass types that we need. And how do we support multiple functions inside that building? This is a perfect example of a great gym. It looks like it's a practice football field, it looks like, inside that aspect, but you're bringing a lot of light in there, but you're also lighting it the right way inside the building to make sure they can see, you know, kind of like a storefront application for a mixed use development. You're seeing everything that's going on in there because you're bringing so much light into the system. So again, how do we support that multiple functionality of the building and what we are trying to achieve inside there? So I think one of the best things is start off kind of the basics of glass and where we start at. So for all those that aren't aware how glass is manufactured, so we take pretty much raw materials of silica sand, soda ash, limestone, and then other materials, and put it into a large furnace. That furnace roughly runs anywhere from 28 to 3,000 degrees, depending on what's happening inside there. And it's going to start the melting process of that. It roughly takes, once we add that material in the back end of the furnace, until we pull it, until it comes out of the float line onto our tin bath, roughly about 2 days. So the material you're seeing cut on the back end roughly takes 2 days from loading inside the furnace to go through the melting process and to be pulled out of the tin bath. After it comes out of the furnace, it's going to go into our tin bath. The reason they call it float glass is because molten tin and molten glass do not stick together. So this glass is actually getting pulled down that tin bath by not sticking together on that material. And then there's what we call attenuators on each side to make sure the glass doesn't crook it around the furnace, the tin bath, that it actually goes straight down the line into making the thickness of glass you want inside there. So we can make either really thin glass up to 2.33 millimeters up into about 15 millimeters in thicknesses on these float lines. The current ones in the US make roughly, the thickest glass we can make here in the US right now is 12 millimeters or half an inch thick. So this is the process of manufacturing glass from start to finish. The next application is going to go into is our cooling system. So we're going to talk here in a few minutes about tempered and heat strengthened glass. When we're making glass, we need it to be in what they call the annealed state, which is it's cooled off very slowly. And the reason we want that is because when you have heat strengthened or tempered glass, you can no longer cut that. So we want to make sure that it's cooled off very slowly, so we're not producing 12 miles of one piece of glass. It can be cut into different sizes and different applications inside this furnace. And then as that cooling process goes along, it's going to be inspected. It's going to be cut to the sizes that we need it for, and then it's going to be packed, and then it's going to either go to our low E coating application that we're going to talk about here in a few slides, or it's going to go into just packing glass and out to our fabricators. They're going to make those insulated units or make those vestibule applications for you, skylights, things like that is where it's going to go into next. So different tints or colors of glass. So obviously clear glass is the most commoditized product that we have in the market. We also have low iron. When we're making low iron, again, what we're doing inside there is taking the iron content out of the sand, and we're pulling that out of there and just making it a little bit clear. Normally from clear to low iron, you get about 2% higher visible light numbers with that. And then, you know, you would apply low E coating on there or however you want to put that on there. But again, you are pulling all the sand, you're pulling all the iron out of that glass to make it as clear as possible, more neutral. So we do have a middle iron, what we call a mid iron glass, or a very close low E called crystal clear. So those all three kind of fall in that clear category we have. And then there's also tinted substrates. And what tinted substrates you're looking at, green, a light gray, and a gray are normally the tints that you'd use. And what those are doing is dropping down the reflectivity of the glass, but also driving down your solar heat gain and your visible light numbers just by the glass itself before you put on a low E coating. If everybody's familiar with the older buildings in the United States, you see a lot of bronze, dark gray. The reason those have those tints, those heavy tints on there, was because before low E coatings really had changed and become very diverse, you would drive down the amount of visible light and the solar heat gain by those tints, and then still applying either a hard coat or soft coat on there to drive down those solar heat gain numbers. So, but now that we've been able to revolutionize some of the low E coatings that are applied on the building, we don't have to use those heavy tints as much as we have in the past. So low E coatings, some people might call them, have heard them called low emissivity. There's also a couple of different types of low E coatings. You can do either what they call a hard coat, which is enamored in the glass. What we manufacture are called sputter coats or soft coats that you might see there. And what we're trying to do with these coatings is obviously maintain the heat transfer inside and outside the building. You know, are we adding it with reflectivity on those coatings? Are we adding it to drive more visible light? It is going to help eliminate some of the glare. It's also going to give it some aesthetic colors as well. Some coatings out there can have a little bit of a blue or some aesthetics like that. And then how much natural light is going to come in the building is also going to be one of the factors on there. Now, there's a couple of different types of low E coatings. You might hear them called double silvers and triple silvers are the ones that are most commonly used here in the United States. And again, what we're adding on there is different metal stacks. And within our double silver coatings would be 2 layers of silver. And within our triple silvers, again, there are about 18 metal stacks on there, and 3 of those being that silver content that's helping grab that heat and bounce it back out of the building to cool off the building as much as possible. So kind of the supply chain that we're looking at. So obviously the design and specifications are going to come from the architects that are driving those aesthetics that we're going to be working with. Where Guardian really falls into those applications and where most float glass manufacturers are going to fall into the raw materials and the float manufacturing and the coating application. Then what's going to happen next, we're going to partner with fabricators across the country to fabricate the units that would go inside that school building for you. And what they're going to do, they're going to take our stock sheets of glass, they're going to cut it down to the size unit that you guys desire. They're going to either create it into an insulated unit, they're going to keep it monolithic, they're going to do a lot of different things, adding, you know, spandrel application on side number 4. They're going to add frit dots if that's something you want to add in there. So they're going to do a lot of the nuts and bolts that you see on the actual building. And then those fabricators would sell it to the installers, also known as glazing contractors. And then they're going to be the ones that apply that glass inside of the building to the desired look and design that you're looking at. The glazing contractors are also in charge of all the metal systems that's attached to that glass as well inside of the building. So kind of Guardian's footprint and what we're looking at. So you kind of see all the dark blue dots is all the Guardian facilities that we have across the country. And then we have several fabricators that you see on there that's highlighted in that lighter blue. Again, we have capacity all over the country, robust supply chain that can really, maneuver our glass around the country depending on where we're going and what you're looking at, and just really connecting with those fabricators. So it's roughly about 126 fabricators that we're partnered with in the US, Canada, and Mexico to fabricate that glass for those particular buildings. And then, so let's now start talking about the insulated glass units. So you might hear me call it IGs. What that means is insulated glass is what we're talking about. And what we're talking about is the next slide here. So you have the monolithic application. Again, a lot of times in schools, we're seeing monolithic glass be installed for vestibules, in between doors and classrooms. You don't see many monolithic insulated units. I mean, monolithic exterior glass. You do in some areas, but for the most part, it's all going to be either what we call double glazed insulated units or triple glazed insulated units. So you kind of start to see, before we get into coatings, anything like that, some different instances where you can really drive down either if you're needing U value, the look you're looking at, the coatings you looked at. And that's kind of the system that you're making up here with these doubles and triple silvers. So monolithic glass. Normally for these vestibules, they'd either be anywhere from 6 millimeters, so a 1/4 inch, up to a 1/2 inch thick. Sometimes it'd be tempered, sometimes it'd be heat strengthened, but for the most part, those monolithic applications. Now, the low-E coatings that we talked about, when you're talking about a soft coat, those particular glass, those low-E coatings cannot be applied to a monolithic application like you see here. Because that silver is corrosive, it does have to be hermetically sealed inside of an insulated unit. So for baselines of monolithic glass, normally these would have no low-E coatings on there at all, and they would really just be to protect something behind that building, during that application. So a double insulated unit IG, so insulated glass unit, you have the spacer in between there. Normally that spacer is set at about a 1/2 inch. And a normal insulated unit for schools that we see is either normally a 1/4 inch on the outboard and a 1/4 inch on the inboard, so making that total insulated unit about 1 inch thick. Normally, in most cases in the United States, the low-E coating we place on slide number 2. I'll talk about the reasons why we might put it on slide number 3 here in the next few slides. But when you apply that to slide number 2, it allows the heat to be bounced outside of the building. So when the solar energy hits the building, that low-E coating is bouncing it or pushing it back outside of the building to help control the solar energy coming inside of it. So a couple terms we're going to talk about here in the next few slides. Visible light transmittance, or VLT. You hear reflectance in and reflectance out of the building. You're also going to talk about solar heat gain coefficient and also U value of these particular glass types as well, and how we can drive down all these different terms just by adding that low-E coating with the correct tinted or substrate that you're going to have on there. And then the next glazing application, these are done a lot. We're seeing it in the Northeast, and these are really to help drive down the visible light, the solar heat gain, and the U value of the building to make it a very efficient unit inside there. So how this would normally go into application, how this would normally be made up, you would have your outboard light on side number 2, which would be the first air pocket. You would have a low-E coating on there. Then you put a middle light in between there, so side 3 and 4. You would also add another low-E coating normally on side number 4, and then you'd have your inboard application facing the students with a 1/2 inch airspace in there to help drive down that U value of the building, as well as all your other important elements inside there as well. Now, with a low-E coating with a double pane glass, you can also, in that same application as we talked about here with the triple glaze to drive down solar heat gain, you can also add a forced surface coating, kind of like a spandrel, but this forced surface coating that's going to be in the viewing aesthetic, this is really to help drive down with an argon mix as your infill, to help drive down that U value of the building about 5 additional points to make that glass in this double insulated unit from a 0.25 to 0.20 U value. So again, trying to make it as an efficient or enhance that thermal performance of that building to, again, keeping the students as comfortable as possible, but also reducing the amount of heat lost and gained through the space overall. So low-E coating, how to enhance that performance and how to really drive it up there. Again, now, as we start to look at lamination application, we're seeing this a lot in school systems just because of the safety concerns. We showed that gymnasium, the football practice field as well. Laminated glass is a great application for safety or for protection inside there. Normally how we see these built in schools is you would have the outboard light with their low-E coating on side number 2, that 1/2 inch airspace, and then a laminated application on side on the inboard light. So how laminated glass works is you have 2 pieces of glass and then an inner layer in between there called, you might hear it called century glass, so SG, you might hear it called PVB. So those inner layers are they stick together and give you some form of protection back and forth and make this a safety glass. Now, as we start talking about safety glazing, laminated glass in its annealed state, so its raw state, is considered safety glass. Also, tempered is considered safety glass in in that state as well. And when we talk about heat strengthened is not considered safety glazing, so, or safety glass. So this is one application that we see a lot. Now, one thing to keep in mind is a lot of metal systems that are used in schools are designed around that 1-inch IG. You do need to make sure that your metal system can incorporate laminated glass inside there. So again, making sure that the metal component for the school and the glass all can fit in the same pocket is extremely important when we're talking to the glazing contractor and everything that goes into that as well. So how do we consider the whole unit, and things we need to think about as well as you're looking from the outside in? There are a lot of different spacer systems inside there to really help incorporate as much heat gained and lost out of that system. So again, you hear things called thermoplasty, which is just a plastic spacer inside there. You hear people talk about warm edge spacer. These spacers are all to help absorb the energy and make sure that your building is as cool as possible. So again, things that you should think about when you're applying just not only that low heat coating, but even the spacer system can help as well. And then next, how do we select that glass for not just performance, but also the comfort, how to make it comfortable inside that school as well when you're looking at it. So really, I mean, you kind of need the best of both worlds. My wife's a school teacher. When I talk about, the perfect learning environment for them, she really, she always talks about that interior illumination inside the building, keeping the temperature as cool as possible. But really that glare, that's one thing that, when I was in school, I didn't have to worry about glare as much because I didn't have computers at my desk. But now that students have computers or laptops at their desk all the time, you really have to start looking at that glare factor inside there. And then how do you also balance the privacy, but also the transparency as well? And then really connecting, the outdoors to those environments of the students as well. So little statistics here that I like talking about. By daylighting that school heavier, roughly about 21% increase in test scores, 1.5 billion potential energy savings by adding that low heat coating. And you are allowing students to have more vitamin D, which are all important aspects when you're thinking about school. But I think we need to first understand what is light. Where does it come from? So obviously you have ultraviolet light, and you also have infrared. And then you have visible light transmittance. So visible light transmittance is really just that percentage of solar energy in the light spectrum visible to humans that is transmitted through glass. And you can either, with those low heat coatings, either, raise it up a little bit. Shrink it down a little bit, or raise it up with reflectivity or different applications inside there. But what we need to understand is how much is enough to bring it inside there. So let's start talking about the foot candles or the Kelvin aspect. So when we start looking at those foot candles for auditoriums, we really want 3 to 10 foot candles inside there. Staircases and the rest of these applications, we can have a lot more light to come in there. As you see there for technical and drawing rooms, up to 70 to 100 foot candles in there, and really just breaking down how much light we really want to circle through that building and be overall inside of those applications to really drive that light or drive that experience for the students itself. So how do we daylight, or what's a dramatic daylighting that we can pull through there? So obviously it really depends on the orientation of where you're located at. Obviously with people in the Northeast or in the northern part of the US, we really want to drive up the amount of light. With the people in the southern markets, obviously bringing it down. Window size and orientation can also change how much visible light we come in there. Also the shape of the building. Is it going to be mostly north and a north and south facing facade? Is it east and west? So those are all things going to change there. And then what type of performance are you really trying to go after? And really that performance, and a great time to start looking at performance of that glass is whenever you start getting, I always tell architects, have me come in the same time you're looking at your HVAC systems, because once you select what your HVAC limitations are, you really can limit what type of glass you can really use in that building without changing the building, without changing the HVAC system for the building, because we can really work in line with your HVAC consultants to really drive the amount of light that you want in there or the heat gain that you could have in that building. So again, this is a good way as we start talking about saving money for the building by picking the perfect glass and the perfect HVAC system. Those are some of the two most expensive parts of a building, is the glass and the HVAC on those buildings. So let's talk about color rendering index and how do we preserve that light. So as you can see here, low iron glass is the highest on the CRI scale. But once we get below that what we consider 90% on the CRIs, is really where architectural quality we start to see, as far as the viewing aspect between there, kind of go away. So again, trying to stay away from some of those greens, the dark, especially in blue. And what we're talking about here is, everybody remembers those sunglasses as kids that were red and blue, and how you could, look at a white car and it looked red or it looked blue. That's what we're talking about here. So we really want to make sure that the viewing aesthetics from outside in is as clear and it's perfect lighting perfect conditions as they go through there. So that's kind of what the CRI, and all this is located when you start talking about glass, of things we talk about. But let's start talking about what happens when sunlight hits glass. It's going to do one of three things. It's going to be absorbed inside that inner layer in between there, in between the glass. We can reflect. So if you have a highly reflective glass, it's going to bounce the solar energy out. If you have a lower reflectance, it's going to drive in more transmitted light. So it's always going to achieve one of these three things anytime sunlight hits that glass. What that low-E coating is trying to do is make that glass perform the way that you need it to for your system. So if we have a high transmitted, let's say the buildings on the north and south side, we can add a lot of transmitted light inside that system and really drive out that viewing aesthetics with the perfect low-E coating. Let's say we want to have some reflectivity for privacy. That's another way that we're going to have lower transmitted light, lower solar heat gain, but adding more reflectivity is going to give you a little bit of privacy inside that system. So again, these three things can really be interchanged. It just depends on what you're looking for, and then using the appropriate low-E coating inside that system to drive these performance numbers that you need. So solar heat gain coefficient, I kind of talked about this earlier. It's really the percentage of solar energy transferring inside and outside of the building. That's why when you go to a triple glaze, you're dropping down the performance even farther with the solar heat gain. When you add that those forced surface coatings, again, you're changing the solar energy that's going to be passed in and out of those systems as well. So light to solar heat gain, this is an important number when you're working with your HVAC consultants, that they want to know. How well is your glass type performing? What's the visible light compared to divided by the solar heat gain? You're going to get a number. If it's a very efficient coating, it's normally in the high, in the mid 2s. So if you look at triple silver coatings, and normally those are going to be in like the 2.3s, 2.4s. But when you start looking at like older single silvers that have high reflectivity, low solar heat gain, high solar heat gain, those coatings would normally be in the mid 1s. So they're not performing quite as well as some of the newer coatings that are coming out. And this number is important because it tells them how important that glass really is, how much it's really helping move and circulate things through there. So U factor, U value, obviously U value is the inverse of R value. Again, just trying to control the outdoor and control the indoor temperature by adding these coatings either on side 2, 3, or even 4, in some cases, depending on what we're trying to go after with that U factor. So again, a perfect example here of a highly visible light double silver. So 68% light, visible light numbers, but the reflectivity is very low. And that's a great thing, because now that gives you a good out to in perspective of that. But you see the solar heat gains right around 0.38. So this would work great in the northern markets, but in some of those southern markets, this might not be a glass type you could ultimately use inside there. Next is an SM54, again, a double silver, but you see how we kind of changed out some of the numbers. Went from, we dropped down the visible light 14 points. We added a little bit of reflectivity to it. So 13, we went from 11% to 13, but we were able to drive down that solar heat gain number by 0.28 from 0.38, just by changing that visible light number. By dropping that down, that allows us to drop down that solar heat gain number as well. So again, looking at ways to drive down that solar heat gain to meet the energy codes that you might want, but also still allowing that visible light number that you need overall as well. And then more of a reflective coating. Again, as we look at these three together, 54 to 43, what do we change here most of all? The reflectivity number went from 14 to 28. We did still drive down the visible light number, and we also drove down the solar heat gain number just by changing the amount of reflectivity coming in the building. Now, this would be great for if you need something with privacy or aspects behind there, if you want to kind of control the view or control the amount of light coming into the building. But these are 3 different ways you can glaze a building to really look at driving down that on a double silver aspect. So again, 2 layers of silver with 11 more metal layers stacked on top of there. Now, triple silvers, again, driving down the amount of light or solar heat gain inside the building just by adding that extra layer of silver on top of there. So again, 62% light, still very neutral glass with 11% reflectivity, but the solar heat gain would meet most of the numbers that you need in every market in the United States by having that 0.27 solar heat gain. So still allowing a lot of light, giving more of a neutral looking glass, but driving down the solar heat gain by adding that extra layer of silver on top of there. And then another triple silver, again, driving down the visible light numbers will also help change the solar heat gain number by adding a little bit of elements in there with some reflectivity. So those are different glass types you can use. Now let's talk about glass for safety, acoustics, and aesthetics of the building as well. So schools, we're always looking at safety, right? How do we keep those students safe inside the building? How do we have clear sight lines? And then also how do we protect them from not only natural hazards, but hazards that might come in or outside of that building as well. So obviously fall protection. We want to make sure that if a student falls and you know, the glass, something happens to that glass inside there, that it is protected from that. Obviously, we're trying to protect some of the natural events as well. Does it need to be bullet or ballistic protected, forced entry, and then anything above overhead glazing we need to talk about as well when we're looking at that. So I talked about this a little bit earlier where laminated glass is safety glazing, but here you see 2 heating elements that you can do inside there as well. So heat strengthen is taking annealed glass, going through a tempering oven and heating it up and then quenching it or cooling it off really quickly to add strength to it. So heat strengthened glass is about 2 times as strong as annealed glass. When it breaks, it is still going to break in large pieces. That's why it's not deemed safety glass. But you still can use this in pretty much any part of that building, otherwise where code requires that tempered glass to be installed at. But again, it's not deemed safety glass. Most schools will be some sort of tempered glass and these different elements where code is required. And what tempering is taking that same piece of glass and doing the same process twice, where it's going to heat up, cool it off, heat it up, and then cool it off. And it's going to add about 4 times the strength of annealed glass. And what that's doing is it's taking the glass in the center, it's making it extremely hard and spreading the strength across there, whether you're in your ends of those IGs are going to be kind of the weakest point, but it's spreading that glass apart and making it very strong. But when it breaks, it's going to break into small pieces. So again, keeping the students as safe as possible inside those buildings. Now, laminated glass, kind of talked about earlier, it's taking 2 pieces of glass and then adding an inner layer in between there and heating that up to make it stick together and adding a safety element inside that building. So when that glass breaks, it is going to stay together in most applications and not fall on the students or stay into the IG. It's kind of the same element. Laminated glass is the same element that goes inside your car windshields. So when that rock comes back and hits it, it's not going to, that rock's not going to come through the system. The same element would go inside this laminated glass. And normally in the schools, we would see that laminated glass be on the inboard part of the glass and having that outboard light just be a single piece of glass inside that system. So what laminated glass also can do is it's not only be a bit of safety, but it also can help with the acoustics of the glass as well. So can help with your OITC and STC numbers, which we'll talk about here in a second, what those numbers, what those are. So it can help with distractions. It's going to keep things that are happening outside, the maintenance guy mowing the grass, things like that. It's going to really try to keep out as much noise to keep it a very, calm, well-being environment aside there. So what is OITC? It's really measuring the sounds through the exterior wall. And it's normally, these are numbers you normally see around high traffic areas, airports, and construction noise is really what those are going to measure for. And then STC is the other element you see, and that's really measuring sounds inside the building throughout. And again, these are mostly done around where we're talking about like auditoriums and applications like that, where we're seeing people ask for more STC numbers, and then OITC is more, busy roads and aspects like that. So again, laminated glass can serve a lot of purposes besides safety inside there. Again, just adding some of those different elements to keep the building as quiet as possible as well inside there. So, excuse me. Other things that laminated glass can add in there is some vibrant colors. So there are ways to add inner layers that can make the glass look blue, green, any kind of aspect you want inside that glass to make it look. There are color inner layers that can help change that color to either add privacy, to add highlights to what the school's colors are. So there's ways inside there as well to add some inner layers that kind of can drive out the overall aesthetics of what the application of the client wants to look at as well. So as we kind of lead into the end of the presentation, the last thing is really to kind of start talking about the spandrel applications and where we look at. So when we start looking at spandrel, we really want to understand, are you trying to blend the spandrel together? Are you trying to make it stand out? We always recommend that spandrel is applied to side number 4, where you're trying to hide columns or, in between floor slabs, just because we don't ever want the students to have a blocked view, but we also don't want them to have where they can start to pick away at that coating or anything like that. It's just really hiding some stuff is really where we try to want to have spandrel. Now, if you're just trying to block out what you can see behind there and not trying to block out columns or pillars, in some aspects, like you see here in this building, we would add an acid etch glass. What would normally happen and what happened in this building here, you added a low E coating on side number 2 and an acid etch on side number 3. And it gives you it allows the same amount of light through the system, but it's just distorting what that view looks like. We do this a lot for mixed use development buildings. We're trying to hide, restrooms or privacy for some meetings rooms and things like that want to be a little bit more private. So acid etch is a good application to still allow the same light, coming in the building. It's not going to help change your solar heat gain at all. It's really just to kind of distort out the figures and things that you see behind there as well. The color laminate, that's something we just talked about as well. This can also be done by our fabricators by adding some different aesthetic viewing inside the system as well for the viewing application by blocking out those amount of lights. We see this a lot in hospitals and also with schools that want to add some diversity to that building as well. And then Frida glass. Normally when we see Frida glass, in most cases, that's going to be on side number 3. And you can really pick out what percentage of frit you want, lines, dots, and different aspects on side number 3, still applying the low E coating on it. What this is going to help do is obviously going to drive down the amount of visible light coming to the system. It's also going to give you a little bit of a better, different viewing aspects as well for those applications. So again, these are some different elements that change out the aesthetic viewing of that building inside the system overall. So as we kind of finish this up, and then I want to do some Q&A here with you guys, again, achieving the right quality, but also the right look for the building, trusting your partners you're working with, getting us involved as early as possible are all things that can help overall not only save your client money, but again, also helping understand the right glass, right performance, and right aesthetics that would be important for that school system overall. Okay. So I'm going to kind of stop sharing my screen and then let's kind of jump into any questions you guys might have.
Right, awesome. Thank you so much, Kreg. So I know we did have some questions that I believe Wendy and Tuan were answering in the Q&A. So some of those might be good to talk through out loud. And just want to remind folks, if you haven't submitted a question yet, please feel free to do that in the Q&A box, or you can also raise your hand. I'll keep my eye on that, and we can unmute you to ask a question out loud. You do not have to turn your video on, so I promise it's not super scary, but if you have like a longer question, that can be an easy way to do that. All right, I'm going to go through some of the ones that have been answered and just kind of talk through some of the answers out loud. So Tim asked, clear to low iron increases cost by about 10%? Question mark. And it looks like Tuan had answered that low iron typically increases the cost over clear by 40 to 45%, and really depends on the exact glass makeup, sizes, and quantities. And then let's see, this person asked, not sure what slide this was in reference to, but doesn't this expose this low E to the interior? We had an answer from Tuan on that The primary low E coating typically goes on the second interior facing surface of the outboard light glass surface of the insulating glass unit, and there are a few low E coatings that can be placed on the third surface, inboard light surface facing the spacer. Room side low E coatings function as secondary low E coatings and are very durable and can be used on the interior IG unit surface to help lower the U value. All right, awesome. Tuan, is there anything you want to add to either of those answers that you've given?
Yeah, so yeah, I think there was Tim about the room side coating had additional question. He said he did show a coating on number 2 and number 4 surface in one of the slides, which seemed odd to me. And yes, it would be, because the room side coating is kind of a new thing. And what it does is you have your primary low coating, which provides the majority of the solar heat gain protection and the majority of the U value insulating value. But the fourth surface coating, it's a very clear coating. It's very durable. And how it works is that it reflects heat back into the room, and that's how it lowers the U value. And for a lot of projects, if you need to hit a lower U value to meet LEED or mechanical requirements, it's much less expensive to do that than to go to a triple glaze unit.
Mm-hmm.
And then back to the question about the low iron glass. So yes, true low iron glass, it's a big upcharge to the insulating glass costs. But there are newer products, glass substrate products on the market now that are called mid iron or close to low iron. And those offer the low iron look at a lower price point.
Mm-hmm. Awesome. All right, looks like we've got a new one. Any recommendations regarding attack resistant glazing or IGUs?
So when you're looking at kind of what would be considered attack resistance, you'd really have to look at, what level or how heavy you want that glass. I mean, you can obviously add any inner layer in that lamination for that inboard light, Kevlar, things like that if you really need something that heavy. But it really depends on the inner layer that you're partnering with to really drive back that. So I know there's products out there, School Guard, Child Guard, things like that. And it doesn't really have anything to do with the glass itself. It's really the inner layer, the lamination piece itself, and what type of inner layer you're putting between there to really achieve that amount of resistance or glass type inside the system. That's really where you're getting all the protection from, is the inner layer itself and how it's driving it out. But one thing to keep in mind too, that when you look at the testing, it's not only the glass and the inner layer, but it's also the metal system around there as well. So you need to make sure that when you're looking for those types of glass, that they have been tested to make sure that the metal is correct, the metal system you're using, along with the correct glass and glass thicknesses to achieve all those resistant applications inside there.
Mm-hmm. All right, looks like there's a question from someone: can attendees receive a copy of the slide presentation? So I guess that's a question for your team. I'm not sure if you share slides directly. I will paste a link in the chat for the place on Acelab where we host recordings of all of our previous webinars. So it's usually a few days before we get a recording up, but you can check back to this link that I just sent over in the chat if you want to go back and rewatch the recording later. Yeah,
we normally don't share the slides individually. If you want to go back, we do have that obviously on Acelab's, as Bo said, but then we also have some on our that are available out there on the web as well, that if you need additional credits or different learning, but we don't share the individual slides, unfortunately, itself.
Mm-hmm. All right. Let's see, from Tim: what's the tallest or longest piece of glass Guardian can provide, and where are the limitations?
So as far as materials with low E coatings, so we can coat up in the United States up to 240 inches by 130. But really what happens next is the fabrication piece of it. And that's where the limitations start to kind of come into play. But the largest fabricated IG that can be produced by one of our fabricators is about 236 inches by 128. And what that has to do with is really the tempering oven they can use, the IG machinery that they have, but also when you take a low E coating, you have to trim off what we call the edge deletion part of the IG as well. So part of that IG already has to be kind of trimmed with a machinery to make sure that the low E coating. So when you take a low E coating and take a spacer system, the spacer will not stick to a low E coating. So you have to trim off a small piece of that to make sure that the low E coating actually sticks to it. But those are pretty much the size limitations that we have here in the United States as far as insulated units.
Yeah, I just want to add to that too. The other limitation is transport.
Yeah.
So a lot of large glass is transported by double drop, because if you use a regular flatbed, a lot of times the height of the glass is too tall and you can't go underneath the bridges. So you have to use a trailer that kind of drops down in the middle. And a lot of those trailers, they have to be limited to 50 or 53 feet. So that also limits the size of the glass. In Europe, the glass is transported slightly differently. They have a trailer that's basically, it's called a, I can't remember the name of it, but it's basically a glass hauler where the glass is on a rack and slides into the trailer, and there's no axle to get in the way. The wheels are kind of loose on the sides. So they're able to do 300-inch long glass, but it has mainly to do with the transport mode. We are looking at figuring out how to use those transport trailers in the US, but there's in the middle of getting it cleared through DOT.
Yeah.
All right. Security film is being used on the exterior side of glass storefronts in some projects. Does this affect the performance of the glass? Is warranty of the glass affected?
So it could have definitely, depending on what type you're using, could definitely affect the performance. I always recommend, in most cases, again, just speaking broadly on glass overall, in most cases, anytime you apply a film on that unit, it does void the insulated unit warranty from the fabricators. But again, I think you need to, check with your fabricator for those insulated units, but also the film manufacturer just to verify what's going on, because what can happen if that glass isn't tempered and you change the heat element, it could heat up. If you use a black film, it could heat up too hot and crack that outboard light if it's not tempered and it's just basic annealed. So that's why I always recommend, kind of looking at who made the insulated unit and who's doing the film, and partnering with those guys to understand the warranty implications as well with the insulated unit.
Awesome. All right. Is low E coating on second surface also for Southeast region, as an example, in Florida?
Yes, definitely down there, because anytime you apply low E coating, let's say you take it from 2 to 3, you're not really changing the visible light number, you're changing the solar heat gain number, because you're going from reflecting or bouncing it out of the building to harvesting inside the building. So now you're allowing that heat to come into the building. So you will change your solar heat gain number roughly about 8 to 10% of that solar heat gain number. So for like a triple silver, that's a 0.27. In most cases, your solar heat gain on side number 3 will now be like 0.35, 0.36. So time in the Southwest and in the southern markets, I would definitely recommend using a low E coating on side number 2.
Okay.
The
awesome.
only time I would say you could get away with it if you use a tinted outboard light in some of those cases, but even there, you might not drive it down low enough to get to it.
Right. Awesome. All right. Looks like that might have been our last one. So I'll just put in one last chance to submit any questions. And while we wait to see if there might be one or two more, I'm just going to do a quick little demo in case anybody joined a bit late and missed our demonstration at the top of the webinar. I'm going to show you guys really quick how to get in touch with Guardian Glass on Acelab. So I'm actually right now on the link for the webinar recordings. So I just sent this over in the chat. Be sure to grab any helpful links from the chat before we jump off today. But here you can see a bunch of resources. We've got, articles, product guides, and then here are all of our previous webinar recordings. So usually takes a few days after a webinar for us to get this up. So check back to this page and you can watch the recording of today's event as well as any of the other events that we've put on. But while we're here, just really quickly want to show you guys how to find Guardian Glass on Acelab. So you can use this search bar at the top and you can type in the name of any brand or product category. Just select what you're looking for. So I'm going to jump over to brands. I can hop right over to Guardian Glass. You can come over here after today's webinar to learn some more about the products. You can get in touch with Guardian Glass directly. So if you have any questions that come up after today's event, you want to connect with them about the project, this is a great way to do that. It really helps to keep all your communication organized, and you can organize it with your project info as well. And scrolling down here, you can save any of these products to your project. That'll put it into like a handy comparison table, so you can see an overview of performance data and information compared to other products that you might be evaluating. But this is a great place to come and, be able to look at some case studies, look at some inspiration photos, save these products to your projects, and, explore some more about some of the topics that we talked about today. So if anybody has questions about that, there will also be an opportunity in our post-event survey to let us know if you would like a quick demo with Acelab. We can show you how to use Acelab to save products, get in touch with manufacturers, and, organize your product information all in one place. All right, let me check the Q&A before we jump off and see if there was anything else there. Nope, looks like we got to all of them. All right, awesome. Well, then I just want to thank everybody so much for coming out today. Thank you for the amazing questions and engagement. We really appreciate it. And thank you so much, Tuan and Kreg, for answering all of our questions. Kreg, thank you so much for presenting. And Wendy as well, thank you for being here. All right.
Thanks, everybody.
Thanks, everyone.
Thank you
Have
so
a good
much.
one.
And one
Bye.
last thing, just feel free to leave any additional comments on the post-event survey. That'll pop up as soon as we end this webinar. So if you had any questions that you didn't want to ask during today's event, that's another great place to submit those. All right, that's it for me. Thank you so much, everyone. Have a good rest of your day.